Our problem, we actually went out and found over at the 134th Air Refueling Wing here at McGee-Tyson in Knoxville. They are a guard unit that flies a KC135R aerial refueler. And on the aircraft, there's a tail stand, which they put under the empennage during loading and fueling operations to ensure that the aircraft doesn't essentially tip over in case it's loaded improperly. And the current tail stand design hinders ground operations. It takes too long to adjust and adds extra fatigue to ground personnel. So our project was aimed at redesigning this tail stand to allow for quicker ground operations, therefore increasing efficiency and effectiveness downrange in combat operations. This is the 3D printed version of our model. Initially, our goal was to design and build the tail stand to scale. It's about 9 foot tall. Unfortunately, cost prohibited us from doing that, so we were only able to 3D print our design. But with further optimization, the cost can be driven down and the model can be built to scale. So initially, we thought it would be a pretty smooth sailing project in terms of designing, building, and sourcing product and parts. What we found out very quickly is we had a really tough optimization problem. The tail stand had to fit in our budget. It not only had to do the job, but perform with a certain safety factor, and it also had to meet certain weight and performance criteria, because the device not only sits on the ramp at the airport, but it also flies inboard in the aircraft in what they call the kill beam bay. It's a storage area, so it does have to meet certain weight requirements. With that, we were really task saturated in trying to balance the cost, safety, effectiveness of the actual device, and weight. So we had to reanalyze our criteria and what we're trying to meet, and then build the design based off that. The thing I think we all enjoyed the most is that if this design is put into effect, it causes great efficiency gain across the entire fleet of this aircraft, not only at this air refueling wing, but across the Air Force as a whole, leading to more effectiveness downrange for our warfighters. The biggest benefit for sure is learning how to solve an optimization problem, learning how to work with the team. There's a lot of us working different parts of this project. It wasn't just me talking. So there's a lot of us on this team doing part sourcing, analyzation of the structural components, and then finally doing the CAD model and getting it all together. So working as a team, communicating, solving that problem together, and using different inputs to solve that was definitely enjoyable, and something we all benefited from.